You guys all ready to go? Okay, I'm only going to cover in the lesson the sine and the cosine sum formulas, but do know that there are other. There's a tangent sum and difference formula. Okay. All right. So here we go. First thing I'm going to talk about is the sum formula for sine. Oh my goodness, all these things are happening. Okay. So if you have the sine of say okay, sine SIG, okay, and I say to myself, the sine of the sine function has to match. So if it's positive here, like x plus y, then in the formula, it's going to be positive in the middle. So those have to match up. So I call those, and I say in my head, I go, those have to match if I'm dealing with a sine function. So the rest of it is just sine x times cosine y plus sine y times cosine x. And that's on your toolkit. Okay? I just wanted to point out to you that these two signs need to match, and the front two trig functions are going to be different. It's going to be sine times cosine. So if I ask you, okay, let's talk about sine of x minus y, then do you think you could write the formula out? If you just know those couple little tricks, it's going to be sine x cosine y plus or minus? Minus sine y cosine x. So again, right, those need to match up. Those match. Now, if you're dealing with a cosine function, the cosine of x plus y, well, cosine is not the word sine, so the signs are not going to match. So if I have a plus sign here, what's it going to be in the formula? A minus sign. But that means they are going to match in the front. So I'm going to have sine x times sine, oh sorry, it's cosine first. Let me erase that. It's cosine x, cosine y, gosh, write a C. Cosine y minus sine x sine y. Okay, so notice that yes, they definitely don't match, right? The signs don't match, but notice that the sine, the trig functions do match in the front end. You catching on to this? It's like sort of a face value thing. All right, so let's see if we could punch out, what would the last one be? What would cosine of x minus y look like? Cosine x, cosine y, plus sine x, sine y, okay? So there's a little trick to help you remember those things. They're on your toolkit already. You don't have to memorize them, but it helps out in a couple of ways. All right, let's talk about what we use this stuff for. Okay, yes, sir?
Can you put a little bit down?
Yes, also note it is on your toolkit, okay? It's the same exact thing on your toolkit. All right, so what do we use this for? How is this important to us in our mathematical careers? We are asked to evaluate the exact value of the cosine of 7 pi over 12. And I want to talk about exact value. When you see this, this means no decimals. This means some kind of a radical sign is okay. Pi is okay. And fractions are okay. It just wants everything except not the decimal, okay? So that means don't use your calculator. So in short, when it says exact value, that means don't use your calculator. Don't use your calculator, all right? Okay, now, let's do this, though. Look on your bite size and find for me the angle. All right, who's got it? Let the record show nobody has it because 7 pi over 12 is not on the bite size. It's not a nice angle. And what I mean by nice angles are 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 130 degrees. No, wait. 120. Sorry, thanks. Yeah. 135. There you go. So the ones that are nice are on the bite size, right? Our unit circle. So the trick is, the hardest part of this problem is finding a nice way to break up the angle of 7 pi over 12 into something that's useful for us. Now, here we go. We could do, how about 6 pi over 12 plus 1 pi over 12? Well, that'd be good because 6 pi over 12 is just pi over 2, and that's on the bite size. But what about pi over 12? That's definitely not. So can you think of some of two angles that we could split them up and use their exact values? Something over 12 plus something over 12. 7. There you go. 3 pi over 12 plus 4 pi over 12. Okay? That's the hardest part of the whole problem. Finding a nice, easy way to break up 7 pi over 12. Now, why do we go this route? Why didn't we just go 2 and 5? Because 5 pi over 12 is not all the right sides, right? 2 pi over 12 is. Okay, can we simplify our fractions? What's 3 pi over 12 reduced to? Pi over 4, very good. What is 4 pi over 12 reduced to? Pi, hey, now we're in business. Pi over 4 and pi over 3 are two angles that we are good at dealing with, right? Pi over 4 is a 45-degree angle. Pi over 3 is a 60-degree angle. We can handle exact values for those trig functions. Do you get the point of that? Great. Now, we have the cosine of two angles being added together. So we're going to use our sum formula for cosine. So we're going to choose to use the cosine of x plus y. Oh, look at that. There's a formula for it, isn't there? That's the one that we're going to use. So this is going to become the cosine of pi over 4 times the cosine of pi over 3, plus or minus, everybody? Minus the sine of pi over 4 times the sine of pi over 3. Now we look on our unit circle. Cosine of pi over 4. We look at pi over 4. Cosine is the x value. So what's the cosine of pi over 4? There you go. Now we're getting somewhere. This is rad 2 over 2. What's the cosine of pi over 3? 1/2. Very good. What's the sine of pi over 4? Rad 2 over 2. What's the sine of pi over 3? Rad 3 over 2. Does everyone see how we're getting those off of our unit circle? That's why our unit circle is super important to have while we're doing these problems. Now all that's left to do is clean this up. What's rad 2 times 1? So this is rad 2 over 4. Very good. Don't say 2. Minus what's rad 2 times rad 3? Rad 6 over 4. So they have a common denominator. So this becomes rad 2 minus rad 6 over 4. And hey, there we go. There is the exact answer for the cosine of 7 pi over 12 that we figured out. Okay? Sine of 17 pi over 12. All right, 17 pi over 12 is definitely not on the unit circle since it's bigger than 2 pi, right? Okay, so who's got a really good idea as to the way we could break up 17 pi over 12? 8 pi over 12, there you go, now you're thinking. Plus 9 pi over 12. All right. Let's simplify. What's 8 pi over 12 become? Two pi over 3. What's 9 pi over 12 become? 3 pi over 4. Can we handle both of those? Yeah, we sure can, right? Okay, good. Here we go. This is the sine of two things being added together. So that's going to be the sine, 2 pi over 3, times the cosine of 3 pi over 4, plus or minus? Plus, because it's a sine. Sine has to match the sine. The sine of 3 pi over 4 times the cosine of 2 pi over... Okay. Bite size it for me. What is the sine of 2 pi over 3? Let's go. 2 pi over 3. What's the sine? Rad 3 over 2. Okay, I'm trusting you guys here. Rad 3 over 2. Good. What's the cosine of 3 pi over 4? No, the cosine. Negative rad 2 over 2. It's okay, you can have a negative in there. Plus, what's the sine of 3 pi over 4? Sine of 3 pi over 2, no, rad 2 over 2, yeah, good. And what is the cosine of 2 pi over 3? Negative 1/2, okay. So this becomes negative root 6 over 4 minus root 2 over 4 which becomes negative root 6 minus root 2 over 4. Okay, we're going to do one more box for the lesson, and then I will do a homework problem for you, which you can choose to write down now, or you can write it down later when you watch the video at home. Okay, we're going to go in reverse. We're going to start on the right-hand side of the equation and figure out what the angle has to be by going backwards. So if I have the cosine of 70 multiplied by the cosine of 20 minus the sine of 70 times the sine of 20, what in the shenanigans is going on? Is it a cosine or a sine function? How do you know it's cosine? Because they're the same up front. See, that little trick helps, right? If they're the same up front, you know it's going to be a cosine function, and you know it's going to be 70 and a 20, and you know that has to be the opposite sign, so it has to be an addition right there. So that's just the cosine of 90, and the cosine of 90, according to the unit circle, is how much? That's the radian, yes. What's the value? 0. Whew. All of this is a fancy way of saying 0. Sweet. So disappointing, isn't it? You thought it'd be this big spectacular thing. Oh, it's just 0. Alright, so you'll have some of those. Keep in mind you'll have some tangent problems as well, but they work the same way. You just have to figure out what the tangents are, okay? Alright, let me do a homework problem for you. You can choose to copy it down now, or you can, watch it later and get it there. We're not going to have time for that. No, we're not going to have time. Section. Secant of negative pi over 12. Okay, well, first of all, we don't have a secant sum formula, so what do? Yeah, there you go. You change this stuff into a 1 over the cosine of negative pi over 12. Very good. Okay, now, we got to find a good way to break up negative pi over 12. Anybody see it? So that's a good thing. I didn't even think about that. All right, so how can we break up negative pi over 12? What's that? Negative pi over... No. How about 3 pi over 12 minus 4 pi over 12? Whenever you can use 3 and 4 over 12, use them, right? So that gives you 1 over the cosine of 3 pi over 12 simplifies to pi over 4, yeah? Yes? No. Yeah. Minus 4 pi over 12 simplifies to pi over what? Pi over 3. There we go. Now we're on target. Okay, now, that's going to be 1 over, since it's a cosine function, I'm going to have the cosine pi over 4 times the cosine pi over 3 plus sine pi over 4 times the sine pi over 3. And that's just using the sum formula, which is equal to 1 over, okay, what's the cosine of pi over 4? Rad 2 over 2, correct. What is the cosine of pi over 3? 1/2, very good. Plus, what's the sine of pi over 4? Very good. Rad 2 over 2. What is the sine of pi over 3? Rad 3 over 2. Now we're getting somewhere. Good. Which is 1 over the square root of 2 over 4 plus the square root of 6 over 4. Which is 1 over square root of 2 plus square root of 6 over 4. And we flip and multiply, which is 4 over square root of 2 plus square root of 6. Now, the book wants you to keep going, and they want you to rationalize the denominator, but that's not what this unit is about. This unit is about breaking up angles. So if you can get to this spot, I will allow you to stop there, because that's assessing the knowledge of the new stuff, not the old stuff. Okay?